Today we are going to be looking at real and apparent depth of objects. I want to believe that some of us will have come across real life situations where you've been to swimming pools and you realize that when you view the swimming pool from the top, you realize that the swimming pool seems to be shallow. But by the time you start dipping your leg or whichever object you want to use to test, you realize that the swimming pool is not as shallow as you think. So this subject helps to explain what we mean by real depth and apparent depth of the swimming pool. What are real depth? Real depth, this is the actual vertical distance of an object below the surface of a denser medium. The medium we're going to be using here is water and glass. This diagram is going to help us explain what we meant by real depth and apparent depth. If you look at this diagram, this is a beaker. This is a beaker containing water. These are water molecules in a beaker. Then we have an observer here viewing the object. The object here is a coin. We have a coin here inserted in the beaker of water. You can see the coin at the bottom of the beaker. Then we have an observer here. This is our air. The observer has viewed this coin from air, and then we have the coin in water, which is our denser medium. The air here is the less dense medium. So we have, this is a position of the coin. Now, if you want to measure the real depth of any liquid, this is the object which is at the bottom. The real depth of this object is the distance of this object to the surface of the liquid, is what we call the real depth. You can see the arrows. The distance from the bottom of the coin to the surface is the real depth. Then the apparent depth, which is the depth at which an object appears to be. When this person views this coin, he sees this coin at this position. So the distance from here to where this coin is being observed by the viewer is the apparent depth. When viewed from a less dense medium like air, which we have there, due to what? Refraction. Now, take note of this, that anytime light bends away from the normal as it moves from water to glass, which we have looked at before, making the object looks shallower. So somebody will ask, why is this object here? Why is this observer observing this to be here? The reason is because when light travels from water to air, and not from air to water, when light travels from water to air, it bends away, light bends away from the normal. So it is as a result of the bending that instead of you having this coin to be at this position, the observer starts seeing it here. So it is as a result of what? The bending of what? Light waves, which is as a result of refraction. So there is a mathematical relationship between refractive index of this glass. The refractive index talks about the rate at which light can travel in a medium. So the higher the refractive index, the slower the light, the speed of the light. So the relationship between refractive index, real depth, and apparent depth is given below. Refractive index, which is this symbol, is equal to real depth over apparent depth. The real depth, we have given it an abbreviation R, and then the apparent depth is A. Now, you can be asked to find any of these terms, whether in WAEC, NECO, and JAM, you can be asked to find any of this terminology. Now, we have one example here. a coin at the bottom of the tank. For instance, if we use this diagram as an illustration, a coin at the bottom of a tank appears to be 6 centimeters deep when viewed from above. It simply means this 6 centimeters is our solution. The 6 centimeters here is our apparent depth, because this is where the observer has viewed the coin. And then when viewed from above, if the refractive index is 1.33, they say we should find its ray depth, R. Now, our formula says refractive index is equal to real depth over apparent depth. Now, if we substitute this, we are going to have refractive index, which is equal to 1.33, and then we have apparent depth is equal to real depth over apparent depth. Our apparent depth is 6 centimeters. So we can cross multiply. Once you cross multiply, you're going to have R is equal to 1.33 times 6. 1.33 times 6. It's going to give us, if you multiply that, it's going to give you 7.98. 7.98 centimeters. Your value without the unit means your answer is wrong. So you must ensure you capture this unit. Very, very important. Now, example 2. The real depth of a swimming pool is, now let's take the parameters. The real depth is 2.5 meters. Then it appears to be 2 meters. It appears to be the real depth. Then the apparent depth is our 2 meter depth. We are asked to find the refractive index. Now, first of all, you write down your formula because the formula carries mark. Very, very important. So refractive index is equal to real depth over the apparent depth. Now you can now substitute. This will give us real depth, which is 2.5, divided by the apparent depth. Now by the time you press your calculator, it's going to give you 1.25. Now somebody will ask, why is it that this does not have unit? This meter cancels this meter. I can do this so that somebody will understand. This cancels out. So it doesn't have unit. Okay? So we have brain check here. If this is clear to you, you can try this at home. We have question number 1, question number 2, and question number 3. For clarity's sake, in case somebody can't see this, this is explain why a swimming pool appears shallower. Explain why a swimming pool appears shallower. Explain why a coin, it could be explain why a coin appears shallower. Thank you very much.